So how do we reverse a three-phase motor? How does a three-phase motor even work? Well, let's start by examining our phase and the rotation of the motor compared to each phase. Now, a motor is going to have a lot more than I'm going to draw as far as coils tied to each phase. I'm going to do it simple. We're going to have 3 phases and 3 poles. First, we'll draw phase. Go here. I'm going to draw a motor. Here's the center of my motor. This is a cross-sectional area. I'm going to put a coil right here. Probably a coil right here and a coil right here. Now, in a true motor, 3-phase motor, you'll actually probably more than likely have coils stacked up like phase 1, 2, and 3, and then there'll be another set, phase 1, 2, and 3, so forth and so on, all the way around. But I'm going to simplify this by just putting 3 coils. But typically, there'll be much more of those all the way around. So we'll start with the first phase, phase A, and we're going to draw it in. And we'll start with, we'll call that A. It's phase A. We'll call this one phase B. And this is phase C. So we see that phase B is leading phase A, and that phase C is leading phase B. So the attraction, if I label these as A, B, and C, we'll see that as phase A rises, well, of course, we have a rotor in here, so we have a little magnetic pole developing in here. But we'll see that A is attracted here. And so we're lining up with A. We're being attracted to this point. As this begins to drop, B begins to run the attraction. And so the poles, the magnetic coil, are going to shift and try to line up with B. So now we're going to line up with B, and that's going to determine our direction. And in this instance, in this drawing, we will rotate clockwise, because once B begins to drop here, C begins to pick up, and so we become attracted to C, and then it starts all over and over and over. Now, typically, you would have multiple coils in pairs of 3 all the way around. And so that determines one direction. So how do we change direction? Everybody got that? You see how we're attracting to each coil and we're going to the right? How do we change direction? Well, if we swap 2 of the wires, we're going to change what leads what. So for instance, if we swap B and C, and B, now what leads on this set of coils? So if we look here, we see that what's coming up next is A. B is down here, but what's in front of A? Not B anymore. C's in front of A. So you can think of it like this. because this would actually be the phase coming through the motor. And now that we have swapped it, we now have C leading A. So I think I moved the wrong one.
Should you have just left it the same?
No, you're right. It moved. C's leading.
But I put it in the wrong place is what I did.
You could have stayed the same.
Yeah, that's right. Sorry. Changed my mind. That's what markers are for. Let's put C back here. And let's put A here. And let's put B down here. So I swap any of the two power leads. And so now when I swap the wires, phase C is leading A. Because the coils are stationary, all I did was move the wires that feed the coils, right? These coils don't go anywhere. I just rearrange the wires feeding them. And so now, if we do that, A is coming up, and now C is following, and after C is B, which in turn means my rotation is changing this direction. And that's how you change direction of a three-phase motor. Now, layman's terms, just swap any two leads. But the reason it does it is because you're changing which coil leads what in the phase, A, B, and C. You're moving that. So you have your attraction here. You could look at it like this. If you wanted to just stack these three coils together. We could just stack up three coils. And depending on what we designated one, if, for example, we went back to ABC here, another way to look at it, B and C, and this is A, B, C, then B leads that, so we're going to spin this way, go in that direction. It's on a circular motion, so it's going to spin that way. If I swap any of them, for example, we put B and A, we put A and B and C over here, now A leads and picks up B, but this is the direction here. And then once B happens, we come back over here, we're rotating around, and we pick up C. We go the other direction. So that's just another way to look at it. Hopefully that didn't make it worse. So let's actually hook up one of these motors.
This is another good reason not to have four-phase, because you couldn't just switch two wires.
No.
You have to really think about it.
You have to start thinking about it then, that's for sure. So here we have a motor wired for low voltage. You guys want to come up here and look at it? Let's start. Don't come past the table. I'm not putting my arc flash on because I'm going to stand over here out of the way and use this button. It'll be 3 foot away. And so here we have it wired for one direction. And I have an amp meter that I'm about to place on one lead. So one of the wires feeding the motor has an amp meter on it. And we're going to generate an EM field. We pull this up a little bit. We can actually see this is a clamp on. And we're going to generate an EM field, and we're going to be able to measure the amperage of this motor. Plug it up, unlock it, get my disconnect on. Let's try this again. And so we'll see that the motor, it's hard to see. We'll see that it is spinning that direction. Let's try that again. And we can actually see the current draw. Now, if we want to change direction, all I have to do is move a couple of wires. So I'm going to change the phases coming in. I can change them at the motor. I've unplugged it. That way I have control of the plug. I'm going to come over here, or I could change them at the disconnect. So I'm going to come over here and simply swap 2 wires. Pull them off, swap them around. Now we'll see we're turning the opposite direction. Luckily, it's a small motor.
Yeah.
Make sure you have your motors secured if they're large. This was a very small motor. But we can see our current draw, and we'll see that right now we're pulling 0.9 amps on this motor. So what if I wanted to check all the phases? Well, it's a good idea to make sure it's balanced, that you don't have one phase pulling another, to check all 3 phases on this motor. So you would simply move your wire, clamp on to another wire, and verify each phase is pulling the same amount. If it is not, something's wrong with your motor, more than likely. So we'll go here. Oh, that fell down. We'll see that it is pulling about the same. Now, another thing is, if we have an ISO cord and we have a motor cable, what if we were to just clamp around all of it, right? So we have a cord. Let's see, we have a cord here. Here's my motor cord. I'll just clamp around all of it and save myself the trouble. I don't have to see those wires. I can just clamp around all of it, and I can read my amperage. How many people think this is going to work? Raise your hands if you think this is going to work, checking amperage around all 3 phases at once. Yes? No? Huh?
It'll say it's read an amperage.
It'll read amperage, but I don't think we'll go
It'll
with tell. Right.
Hope you're right.
Well, it'll probably read something, but it won't be right. Let's see what it reads. Oh, no, we don't get anything. Of course, that depends on the meter. If I were to pick 2 phases, I can read something. But because I'm reading all 3 phases, the EM fields cancel one another out, and I don't get anything. So it's not accurate. If I were to come over here and try to check my current draw, let's see. We'll read something on 2 because we have one of them that's not canceled out. So if we come over here and we try to check current draw, now I have 2 of the phases, and I'll read slightly less than what I should, but when I have all 3 of them encapsulated inside the little coil on the meter, I read nothing because they cancel them out. So if you see somebody pull out a clamp-on probe that only works on AC and clamp it around an extension cord and say, I don't know, it's not working, they don't know what to do. Now you do. You've got to check each individual wire. If you check them all, it's going to cancel itself out.